4.3 is VSEPR Theory. I want to say the shape of the molecule. We know the octet rule. Based on that, we can draw the shape of that. So Be, note you have a 2 valence electron and H has 1 valence electron, H1 adding cell. So there is no lone pair on Be. That's why it's going to be a straight line, right? If you had a lone pair in the middle, it pushed this bound down and it would bend, right? But since there is no lone pair electron here, it is just a straight. So we call this shape to be linear. And the general formula is AX2. Total pairs, we have a pair of electron here shared, it's the bound. So one pair of electron here is shared, it's the bound. So total pairs, lone pairs, we have nothing. On BE, you don't see any lone pair electron. Bond pairs, of course, is 2 bond pair. So here is AX3. Okay. BH3, B has 3 valence electron. You just put it there. H has 1 valence, of course, 3. Since there is no lone pair electron here, this bond will be far away as possible from each other. We call it trigonal planar because they are kind of in a plane. The plane can pass through all these 3 bonds. So total pairs is 3. As you see the electrons here, and it's 3 of them. Lone pair we don't have on a central, and bound pairs are just 3 bound pairs. Stage 4, you know that. So it's we have 4 bond with hydrogen. It's 4 valence electron. That's why I make it 4 bond with hydrogen. We call it tetrahedral. The formula is AX4. There is 4 pair electron, as you see. There's 0 lone pair. You don't have any lone pair on C. Bound pairs is 4. NH3 and N has 5 electrons. That's why in valence, Cn has 1, 2, 3, 4, 5. Okay, so the hydrogen come, it make a bound with it, right? These 2 lone will push this bound down, like they repel this electron. That's why it is bending a little bit. It is pyramidal, we call it tetrahedral. Is AX3. X is the number of the bound. So we have 3 of bound. And E is a lone pair that you see here. We have total 4 pairs. These 2 pairs, which is lone pair, 1, 2, 3, 4. The 4 lone pair. But 3 of them is bounded and 1 of them is lone pairs. H2O, we did draw that before. H2O, because of these lone pairs, they push the bound down. They call it V shape. When you have 2 lone pairs in the middle, it is a V shape. The total lone pair is 4. 2 of them is a lone pair, as you see, these 2 lone pairs. And we have 2 bond pairs. And this AX2E2. X is the number of bond, it's 2. E is a lone pair. We have 2 of them. Next one is HF. HF is easy. F has a 7 electrons. 1 electron is available to make it to be shared with hydrogen. So it's a linear shape. As you see, around floor, we have 1, 2, 3, 4, 5, 6, 7. Right? One of them is shared with that. You see the lone pair 1, 2, 3. We have a lone 3 lone pairs, and we have totally 4 pairs. That 1 of them is a bound with H. Oh, I could show that to you guys. Anyway, so here is more shapes. CO2, again, it's going to be linear. If you just draw BF2, BH3, it says trigonal planar. You can try that. CH4, we did talk about. SiH4 is the same. NH3, PCl3 is the same. You have a lone pair here. H2 and OCl2, we have a 2 lone pair of electron, so it's very bending. And here's that. So this is like a summary of that. So let's just see how do we do SO4. S has 6 electron in a valence. 1, 2, 3, 4, 5, 6. Oxygen has 6 electron in a valence. 1, 2, 3, 4, 5, 6. What else? See if I have another question. 1, 2, 5, 6. Another 1, 2, 3, 4, 5. Okay, as you know, we have this 2 negative means I have 2 electrons need to give it. Oxygen is more electronegative. That's why I can give one of the electron to this oxygen and one of the electron to this oxygen. Then there is a 1 electron. I can make a bond with this. They can be shared. And here this can be shared. So this single bond here. And for this oxygen, this electron can come here. I'm gonna erase that. And this electron can come here as well. Let me just grab the pen again. Here is my oxygen here, guys. So this electron comes there. The electron was here, now here. The electron was here. I'm gonna put it there. Now we have an empty space. These 2 electrons will become to be shared in this empty space. These 2 electrons will become to shared between these empty. So I have this electron there. So if I have a 4 single bond, you see here, and then I have to put a bracket around that and put the 2 negative here. This is iron. Now here is B2F4. B has 3 electrons. 1, 2, 3. And here we have another B. 1, 2, 3. Between them will be a bond, and I have a 1F here. 1, 2, 3, 4, 5, 6. The 7, right? The same thing. 1, 2, 3, 4, 5, 6, 7. I did the same thing here. 1, 2, 3, 4, 5, 6, 7. And 1 up here. 1, 2, 3, 4, 5, 6, 7. This electron will come here and make a bond. Electron will make a bond here. This long electron come and make a bond here, here. But you see we have 2 bonds with F, so this is especially, they need to be as far as possible. So to get that, so for the practice, you can do question number 2 and 3. Now here is another one, PCl5. Sometimes you can make a bond with extra. So S, you know, is 1, 2, 3, 4, 5, 6, right? And you have F6, you know, F just has one of the electron can be shared here. So one of the electron can be shared here, but these 2 kind of will separate for the other F. So F can share here, F can be shared here, and 1 F can share the electron here, and another F shared the electron here. Kind of they need to be unpaired first, and then they can come and be paired with that. That's why some exceptions. The same thing for PCl5, you can try that. So multiple bonding whisper. So it's just a C2H4 that I have shown this one before, and C2H2 I have shown this one. Let's just look at NO2. N has 5, right? 1, 2, 3, 4, 5. Oxygen have 2 oxygen. 2, 3, 4, 5, 6. One of them is here. and one of them 1, 2, 3, 4, 5, 6. This is negative, so oxygen is more electronegative. So I'll give this electron to oxygen, then this will come and share the electron with this, and these two here. So you have a lone pair on N that is here, and 2 bond with oxygen, single bond with oxygen, and we need to put that in a bracket, and I need to put a negative on the top of that.